Hello, this is Ian Woolf, producer of Diffusion Science Radio. You can now support Diffusion through the Patreon support page at patreon.com/diffusionradio. Send me a message about the supporter awards you'd like to receive, or make a donation directly with the PayPal button, or click on an Amazon affiliate link at www.diffusionradio.com.
Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your brain. I'm Ian Woolf. On this edition, 3D printers for children, Internet Barbie dolls, and how to become an emerging technologies developer. But first up, here's the news. Carve your own ear? Researchers from the publicly funded Pelling Laboratory for Biophysical Manipulation at the University of Ottawa have found that apples can be carved into shape for scaffolding to build organs with stem cells. It's long been thought that you need to build scaffolding for new organs from donor organs. Donated organs have their cells removed with a kind of detergent until the only thing left is cartilage. This cartilage is seeded with stem cells from the recipient, and a whole new organ is grown using the cartilage as a guiding shape. Recently, a human heart was grown by stripping cells from a donated heart and reseeding the cartilage with stem cells from the recipient before transplanting. It's expensive and risky, as any cells left from the donor can lead to a severe immune reaction that often kills the recipient. Synthetic materials can be used, but they cost many thousands of dollars per organ. Traditionally, it's been thought that the only way to reduce or eliminate the risk of immune rejection and keep the transplants affordable is to use donor organs as close as possible genetically to the recipient. Professor Andrew Pelling took a creative step sideways and wondered if what you really need is the exact opposite, something as far from the recipient as possible genetically. How about using common plant fibre as a scaffold? Specifically, apples. Apples are cheap and they grow on trees. Andrew Pelling has apples hand-carved into the shape of human ears by his wife. The process developed by their PhD student Daniel Modulewski is to slice an apple, wash it in soap and water, then sterilise it. It's a similar process to how a donated organ is stripped of donor cells. What's left is a fine mesh of cellulose which you can inject with human cells, which then grow very well. The researchers found that when they implanted the apple-based ear under skin, the surrounding cells enter the mesh and send out signals to create a blood supply, and it becomes a living part of the body. Apples are not the only plant with useful cellulose to be carved into a scaffold to grow replacement human organs. The researchers are experimenting with asparagus, pears and mushrooms to see how their structures may work for repairing bone, nerves and skin. Seed grants have allowed the lab to test preclinical safety and compatibility of implants in mice. For now it's just ears, but in the future they could replicate growing adult human hearts from stem cells or grow other organs. The lab has spun off a company, Spiderwort, which sells kits for do-it-yourself biologists with the hardware required to make cellulose-based biomaterials and the incubators required for growing human and animal cells on the scaffolds. The incubators are essentially warm boxes, 37 degrees Celsius, that control the carbon dioxide content in the atmosphere. The company is working on a larger open-source platform for biological hardware and wetware, aiming to enable everyone from do-it-yourself citizen science labs like Sydney's Biofoundry, university labs, and even hospitals to create these biomaterials for themselves. You could use an organ scaffold factory cut from an apple, carve your own replacement organs, or pay an artist to create something just for you. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. And now part 2 of Developing with Emerging Technologies. Patrick Catanzariti is the founder of DevDiner, which is a website for developers looking to get into emerging technology. Pat's also an editor at sitepoint.com, where he writes how-to articles on all sorts of emerging technologies. We got together at the Ashfield Club where I continued the conversation by asking him, had he heard of Mattel's 3D printer for children?
I did hear that, which is good. I worry that it will be no better than just getting a normal 3D printer, or that it will be made to a bit of a lower quality because it's for kids, I guess. Like, you don't want to build something with the highest quality materials when you're making it for kids. But at the same time, I think it's great in that Mattel owning that sort of intellectual property is great in that they can join many different things together. So they own Viewmaster, so they can theoretically combine that, make an app for Viewmaster, which kind of works with the 3D printer. And for me especially, I think that's good in that getting kids to look at that stuff early and showing that it's possible early on. So if Mattel are able to go and make their 3D printer, which works using a Viewmaster where a kid can look through their Viewmaster device, click settings to change a 3D model that they're going to create, and then have it print out for them based on what they've selected, for example. That alone isn't that complicated to do from a technical perspective, especially if Mattel owns both devices. They can literally just be like, hey, there's no reason to not do this. But from my perspective as a developer and trying to get the whole industry to keep moving forward, that's the sort of thing which helps children as well see that, okay, that's the baseline now of reality, is I'm a kid and I can go off and put on a headset and make something happen, which then gets printed out and becomes a real thing. So rather than that being the awe-inspiring reality, after about a week of a kid doing that, that's just normal. That's what they've grown up with, and that is not exciting. Every adult will be like, oh my gosh, you did what with your glasses? That is unbelievable. And so adults won't see the same possibilities now that these kids who've grown up with that as their baseline will see. And it's going to keep growing. I think Mattel are doing great in that they're really trying to innovate. So they've done their smart Barbie, which has had many, many, many people complaining about it as well and thinking it should not be created, and many privacy advocates being like, I don't want them recording my children. And those are fair concerns at the same time. And some people have said everything from having a Barbie which is responding to your child based on it trying to learn what the child is saying and interpret it and respond takes away the child's imagination and is a little creepy. And the fact that Mattel then starts to get a little bit more control over how kids are being brought up. I mean, Mattel gets to choose what phrases Barbie is going to speak back and that sort of stuff. And so there are a lot of people who hate that idea, who are like, I want my kid to be learning and developing as they want to learn and develop. They should have their imagination. They should do this and that. I think those are valid concerns, but from the perspective of getting kids to really open up their minds and see what's possible, the world is going to become one where there are going to be AI things everywhere. That AI interfaces where you speak at them and it returns back information, like we said at the start, is already happening. And having toys which do the same thing is inevitable. If everybody yells and screams and Mattel doesn't do this, then somebody else will. So it's good in that way for Mattel to do it. And from the same perspective of getting kids to open up their minds and see this as a baseline possibility, Mattel having, say, Barbie as well, and they have a smart home coming out for Barbie, so small dollhouse that can connect to the internet and do cool things. All of that stuff really sets up kids early on to see, okay, this is what's coming. If I want to have a house which turns lights on and off automatically via technology, this is a thing which exists and is possible. And if I can have my Barbie and I tell my Barbie to do something like, hey Barbie, can you turn off the lights? Which I don't know if Mattel are doing, but I'm going to assume they are. That's the sort of thing which is pretty cool, and it empowers kids as well. If people are really worried about it, if people hate the idea of Barbie being able to record your children and hear what they're saying, and likely have conversations about really kind of, I guess, intimate thoughts that kids have, because kids trust their toys and will say almost anything to their toys that they will not say to their parents, The best solution, I think, going forward is going to be limiting how often you let your kid use it, or I guess watching what they do and making sure that they have other toys as well which don't listen to them all the time, so that there is a bit of variation there. And I guess, yeah, it's more of a monitoring and taking care of things, making sure that if you really want your child to not have monitoring 24/7, just don't have the Barbie with them all the time. Say, okay, Barbie is going to sleep now, or she's going to visit somebody else and is gone now. Play with your other toys. But I think it's bad to limit it, because kids who grow up with that stuff have huge potential. The other thing that I wrote about recently, which has got plenty of argument back and forth on Reddit and stuff, was me talking about how I was over the fact that always when people mention artificial intelligence, there's a ton of doom and gloom about how the world is going to end. Recently, it was 50% unemployment, half the world's going to have no jobs anymore because AI is going to be so smart that it's just going to do everything that half the population already do. And the world is obviously not going to be able to handle this, and there's going to be chaos. And while I disagree with it, and I think it's clearly something where the world will adapt, we'll slowly have new jobs and new possibilities, things will appear. For me, this is one of those ways where these kids who grow up with this initial stuff of, okay, AI exists already, I'm working with AI all the time when I talk to my Barbie in my smart home, with my Viewmaster or my 3D printer. That stuff means that kids who grow up with that will come up with new ideas. There'll be new career paths for them where they've grown up with this baseline and they go, okay, I now want to get involved in making the next smart Barbie. That can be a completely different concept that we would not even begin to imagine, because the way we're thinking is coming from, I guess, the sci-fi worlds that have already been kind of discussed, and everything that we've got in mind doesn't really come from the same level. So I think all of this, Mattel especially, and Disney are doing a great job in having all of that there, because I think it's really going to help spur on the next era of innovation in about 15, 20 years when these kids all start to actually mature enough. I think that by about 14, 15 years old, they'll be able to code. So assuming that they've been taught to code, which I hope they have, they'll be able to do some pretty cool stuff.
Do you think most of the privacy concerns aren't really about AI? It's about AI that's in the cloud back at headquarters, where people can listen in and people can have input, that people are worried about more than the fact. So if it was AI that was just in the Barbie or just in your TV or just in whatever Internet of Things device, if it wasn't on the internet, perhaps it was just a smart thing, people would be less worried?
Yeah, I think that's a very good point, and it's true. I think having all this go to the cloud brings a lot of, I guess, necessary trust that you have to have with the companies that are doing it. And a lot of the time that trust is going to be tough to give, because technology companies are run by people. And while the people may not have malicious intent, I would say majority of these companies who are building these devices and such, they're good people who are really trying to just make nice things that will help make people happy and make life easier. The difficulty with it is that they are people, and while they're very, I guess, positive in their intentions, they make mistakes. Developers are people, and there are deadlines and easy ways of making mistakes. It's also constantly changing, so while they may make a flawless application for Barbie, for example, the chances are that technology that Barbie has been built upon within 6 months to a year will have security flaws which have emerged, where some basic principle that the Barbie was built off, which wasn't something that the developers who made Barbie made, say an existing technology for connecting it to the internet in a certain way, which is used by everybody who uses technology to connect to the internet, basically, could have a flaw for whatever reason. Somebody realizes, hey, if I send off this random string of numbers and letters at this very commonly used system for connecting to the internet, then I can jump in and make this device do something that it's not supposed to do. And I can guarantee that Barbie will have that at some point there will be a huge flaw in something which may or may not be Barbie and Mattel's fault, which opens it up to all sorts of privacy concerns. The danger with it is, even though it's dangerous because it's connected to the internet, it's also dangerous in that that stuff isn't able to be reined in. Like, you can't say, okay, there is an issue now, let's just stop it forever and not do any more internet-connected devices. That's just not possible. And it's already started, so it's hard to say, oh, we should just not do it now. Technology is evolving in that direction. The safer way that I think we're going is better education in terms of how to have these devices on your internet and your networks and stuff. So rather than doing it the simple way of just saying, I've connected Barbie to the home network, and so technically somebody hacks into Barbie, they get into the entire home network, and suddenly they've got access to my Mac and my server, which I'm stored all my music and illegal movies on, and now suddenly Mattel has all this information about how I've got illegal movies. I don't have illegal movies, by the way. I'm completely against that too, but that's a whole other topic. But theoretically, those concepts and those issues go away with the right sets of knowledge and stuff as well. So over time, we're going to have better education and, I hope, better network equipment as well, to say to people, okay, you have a network full of devices, but this network should not be just one network for all of your devices. If there is a dangerous device which you don't want to just have access to everything on your network, or you want to maintain it and be careful and see what's going on with, say, this set of devices, there are ways to set up networks where you can have things segregated to say, okay, these devices should have a limited amount of access to the internet or a limited amount of access to everything else in my house. Don't give them that access, sort of thing. And so in one way, I think some of these privacy concerns will be reduced over time by the manufacturers of routers and stuff who think and approach it from that perspective of saying, okay, everybody's going to have smart devices. We will give them more control over what they can and can't access. And if somebody, a big company out there, I should do it if I had time, but I won't because I don't have time, is having a way of monitoring it all. And somebody, I'm sure, is going to come up with a way to monitor internet traffic through home networks and be able to alert people and say, hey, this Barbie device is doing something weird that it doesn't usually do. Check that out. Probably turn off Barbie. It's doing something stupid. It shouldn't be sending off all of this information. So that'll happen. And in the long term, I'd say it's still quite far off. But eventually, Barbie won't need to be connected to the internet to say all this stuff. Eventually, technology will advance to the point where everything can be contained within your home network or within Barbie itself. And we won't have to go to the internet to say, okay, what did the child say? Interpret it, say what to say, and back. Eventually, technology will be so good that we won't have to go to the internet for this sort of functionality. It'll just be self-contained. And that'll be lovely too, but it's still a long way off. There are companies like Google who would love to not have it all going through the cloud because it opens up the technology companies to a lot of criticism as well, where everybody assumes that Google and Samsung and all these companies are spying on them because they've got devices with microphones in their house. And Samsung is a whole different story. They're actually worrying some of the ways that they do things. But Google especially are quite good in that they are genuinely trying to do things in a very privacy conscious way, where literally Google doesn't send off information about what you've said unless you say the two words, which I won't say because I don't want to set off everybody's devices now. I'm learning not to say this. But once they say those two words, then it goes, okay, you've said something that you want Google to look up now. Now I'll start sending this stuff to Google. Barbie maybe will have the same thing, and that could be good as well, in that, at the very least, things that you didn't want Barbie to be hearing and sending off to Mattel shouldn't be going to Mattel. It should be, if the kid has said, hey Barbie, or whatever, I don't remember what the word or phrase is that sets it off, and then starts talking, that'll be sent off. And while that might not be great, in that the kid may still say things that it shouldn't be saying, it's still at least a little bit better, I guess. So, yeah, summary of the answer is just there are so many ways that it's going to evolve still. Privacy is a big concern, but it's something where as long as the industry is still working to meet it, which it is, it's not like we're creating these devices and the technology companies are just saying, stop complaining, it's wonderful, we're not going to fix anything. They are looking for ways, and over time technology is going to evolve and get better. It'd be good as long as people see that the companies that are doing it in a responsible way are the ones which are used, and the companies who are not doing it in a responsible way are forced to change their ways and adjust their course of action and that sort of thing. So, yeah, I think that's a good answer to your question.
So, if somebody wants to study to develop emerging technologies, what should they study?
That's a good question, and I don't actually think there is any course out there at the moment that meets this sort of thing anymore. I think most IT and computer science courses, which teach you the basics of programming and stuff, are great. I think computer science courses are the better options in that a lot of the time they will delve more into the really technical side of programming and programming languages, how they work. They'll delve a lot more into electronics sometimes, and that can be really good to know. There's a lot of stuff which I never learnt at university, not because it was a bad university, it was an incredible university, but I did a Bachelor of Information Technology, which was very focused on business and consulting and taking requirements and helping that be translated into a solution. And that stuff is very useful and is used all across the industry. But for more emerging technology stuff, the main stuff that I learned at uni that was useful was the programming subjects. This is how you code, this is how you do databases, this is how Linux works, and this is how you go into terminals and you set up commands and you make things happen. And all of those basic computer concepts, I think are covered a lot more in depth with computer science itself. So if you go into computer science and engineering, that's a little bit more, I guess, beneficial for somebody who wants to know a lot about it. But even those, you will come out of it still not knowing everything you need to know. One person I know who I was talking to who went to Sydney University and they did a computer science degree and they still don't know how to do basic stuff. Or they're still trying to work out how to do basic stuff with Arduinos and stuff, which is still quite simple. But the difficulty with emerging technology in general is that it changes constantly, and all you can really have is the basic knowledge of how to program, how to learn stuff really quickly, how to find the information you need to find, and then adapt your knowledge to new stuff that's come out. So even though there are people out there like my friend who did all of the computer science degree, they know all of the ins and outs to really, really deep levels of how programming and the inner workings of a computer work. They know all that stuff, but then you still have to go out and learn, okay, I want to develop for virtual reality, what do I do? And you're still going to have to go and learn whatever the latest program is to do it. So one of the reasons why I built DevDiner up is my website has lists of guides which set up where you've got to go to find stuff. So if you want to develop for virtual reality, I've got guides up on DevDiner which say, okay, you want to work on virtual reality with Unity, which is, well, I guess I kind of start out a bit more broadly and just say, you want to work with virtual reality, here are your options. The main one that everybody uses at the moment is a program called Unity. Here is a list of links to where you should go if you want to learn virtual reality and Unity stuff. And I do a lot more specifics of saying, okay, Google Cardboard is great, it has an API, you work with it with Unity, here is a list of tutorials, go there, learn them, you'll be able to do what you need to do and adapt from there. And similarly with things like smartwatches, leap motion, and doing hand gesture detection and stuff. All of that stuff, it'll change constantly. Even if you've spent your entire year learning how this stuff works, the year after there'll be updates and changes and you'll have to relearn anyway, some of it. So it's much better to just know the concepts and work from there. If you want to learn anything to do with emerging technology, you should go to my website at DevDiner. And then if it's not there, you should email me and say, hey, Patrick, I want to learn how to do this thing. I can't work it out. Because then I can kind of add that to the site and slowly build it. So the idea behind it is that while I'm kind of moderating everything and putting everything up, I want it to be very community focused where people can tell me what they can't find. And it can very much be a help to everybody else afterwards. So I've had people come to me, especially with Google Cardboard in particular, where there have been people that have Windows phones who wanted to do Google Cardboard stuff, and they wanted to know, can that even be done? Because it's a Google Cardboard device, and Microsoft don't really have a Google Cardboard API or anything. How do I do it? And so I went off and found the information, and then emailed them back, put up a link on my own site as well with a quick guide to say, if you want to do Google Cardboard with Windows Phone, this is how you do it. Go to these links, they explain it more. So that's kind of the way to go. A lot of the time, if DevDiner doesn't have it and you really urgently need to work it out, you have to search through forums and you have to do a lot of Google searching and hope for the best. If you're really, really early with these things, like I am a lot of the time when I'm doing tutorials and stuff and I'm writing about new technology, sometimes it's stuff which nobody has worked out yet, or the people who have worked it out haven't written about it. So you just have to trial and error and hope for the best. And that's kind of the best you can do. So it really depends what stage of emerging tech, but the best way to do it is just tinker away, trial and error, keep working stuff out, do lots of Google searches, contact Patrick, he will find information and answers for you.
Well, Patrick, thank you very much.
My pleasure, it's been fun.
That was Pat Catanzariti from devdiner.com talking about his favourite emerging technologies. And that's all from us this week on Diffusion. Would you like to join us? We need more people contributing stories to Diffusion. You can send your contributions, opinions, congratulations, standing ovations, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com, and please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Check out our Patreon page at patreon.com/diffusionradio. And write to tell me what sort of supporter rewards you'd like. So far, stickers, t-shirts and nano drones have been suggested. Should the stickers and t-shirts be of the Diffusion Plasma Ball logo or something else? Checking production was Charles Willock. I produce Diffusion, which is broadcast around Australia on the Community Radio Network, including 2MVR in Nambucca Valley, 2XX in Canberra, and 3MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, then explore more than 700 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick. Everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.